day, everyone. So for the fifth problem, we have the member shown in the figure is being connected at A and rest against at a smooth support B. Determine the horizontal and vertical components of reaction at point A. So in our figure, we have the support, which is we have vertical reaction and horizontal reaction. So the vertical reaction, we label this as AY, and the horizontal reaction is AX. Next, first is we are going to solve for the moment A. So for the moment A is equal to 0. So the moment A is negative 90. It's negative since we are doing the moment counterclockwise. So negative 90 nm times the distance from point A to 60 meter is 1 meter. 60 Newton is, the distance is 1 meter. So times 1 meter plus the unknown force is NB. So NB. So times the distance from of 0.5 meter, and that is equal to 0. So now in order to get the value of NB, if we put this in our calculator, we will have the value of NB is equal to 200 Newton. So now, the next thing that we are going to do is we are going to solve for the forces in the x-axis and the horizontal axis. So summation of forces along x is equal to 0. So AX is positive AX since it's going to the right. So AX minus the distance of 200, which minus the magnitude of 200, Newton, sine the angle theta of the NB, which is, you can see in the figure, it's 30 degree. So sine 30 degree is equal to 0. So if you are going to calculate this using our calculator, we will have the answer of the AX is equal to 100 Newton. So now, we have the value of our horizontal component, which is the AX is equal to 100 Newton. Now we are going to solve for the vertical component. Vertical component is summation of forces along Y is equal to 0. So AY minus the 200 of NB, the 200 NB cos the angle of the NB, which is 30 degree. Cos 30 degree minus the magnitude of 60 Newton. Newton. It's minus since it's going downward. Minus 60 Newton is equal to 0. So if we are going to solve this, we will have the answer of AY is equal to 233.305 Newton. So now we are going to plot this in our given figure. NB is equal to 200 and AY is equal to 233.05 and then AX is 100L. And that's all the answers that we solved for the required. Do you have any questions?
So here is another question about or a problem for the equilibrium of rigid bodies. The uniform rod AB has a mass of 40 kilograms. Determine the force in the cable when the rod is in the position shown. There is a smooth color at A. So as you can see here in the diagram, point A has a smooth color, means that it has no friction and no resistance along the rod. So the mass is given. So usually we neglect the mass or the mass of the beams. But in here, in this question, we include all the forces that are being applied to our free body diagram, or what will be going to our free body diagram. So we have a tension here, which is in the line C and B. So the tension here will be E, C, B. So here at point B, we only have one reaction, which is By, and it is acting on its vertical direction. So as we distribute, or this problem has a distributed loading, but we can also find an equivalent point of the forces. So in weight will be acting here in the center. So weight is given, which is 40 kilograms. So 40 times 9.81. So at point A, we only have one reaction, which is in the X direction. Okay. So now we have our free body diagram. So now we can sum the moment of the equation. So first, summation of moment is equal to 0, and it is acting on its counterclockwise direction. So first, we're going to find the rotation here in the center, which is the weight. So 40 times 9.81. Then, as you can see here, the beam has a length of 3 meters. Since the weight is in the center, we need to divide, or we need to identify the half direction, or half, or the half of the length of the beam, which is 1.5 meters. So we also need to consider that there is an angle there, which is 60 degrees. So here 30, I mean 3 meters. So at this side, this will be the x component. So 1.5 cosine 60 degrees. So here at the vertical component, which is the 3 meters, the length of the beam. So as it lies in the vertical direction, it will be on the y component, which is 3 sine 60 degrees. So now, as we rotate, or as we see the moment, like the forces of the wave rotates on the counterclockwise direction, so it will have this times 1.5 cosine 60 minus, since the direction of our tension is going to the left, so it's going to be negative. So negative ECB times the length of the beam, which is 3 meters, 3 sine 60 degrees is equal to 0. So to calculate and to find the value of TCB, if you calculate it in we solve it using by our calculator, or we calculate it in our calculator, the answer will be 113.28 newtons. So the only forces that are going to create, as you can see here in the free body diagram, the only forces that are going to create a moment will be the W and the tension, which is the TCB. So first we are going to find the moment arm of the W, which is 40 times 9.81, and then the distance, which is 1.5 cosine 60 degrees, and